Hey everybody, this is Mr. Storm. In this video, we're actually going to handle some more environmental controls, some things that make the game playable, but they're, basically just finishing up all of our movement. We're going to do two main things in this video. We're going to create a robust camera follow script that we can use for really any project we want. The script we write is going to be pretty universal. So we're going to create that and attach that to our camera and then get that working. And then we are going to create a parallax system where let's take a look here. So we have a parallax camera setup. We have three objects. We have this static object. We have a background object, which is the mountain. And we have a foreground object, which are these closer mountains. And we want the mountains to be kind of moving in relation to where the main character is, so it looks like there's some 3D movement or there's some depth to the game. And we're going to create a script that handles all of that. The first thing we want to do, however, is I've noticed that when I was playing around on my game here, that I was sticking to some of the edges on these walls. I was sticking to them. And we can fix that. Now, there's a really easy way to fix this. If you select the ground object inside the grid and come over here to the Composite Collider 2D, there's a spot for materials. Now we have a material, a physics material called slide, which basically turns off the friction for an object. So if you grab this slide material and drag it over into physics material 2D, then it'll work. And we won't actually, we'll slide down the walls. We won't actually stick to them anymore. So I would go ahead and add that if I were you. That will be helpful. I have my handy dandy Super Nintendo controller here. I'm going to be using this to test my game. Let's review what we went over so far. So I have a character. I can move and I can jump, and yeah, I'm just pushing buttons on my controller. All right, perfect. And I can't jump twice, which is good. I can't double jump. All right, so now we want that camera to follow us when we move around the game. Let's go ahead and create a new script. And let's call this cam follow. Now, like I said, this is going to be a robust camera follow script. You're going to be able to use it for every project that you build on your own, because hey, this is the last project we're building together. So from now on, you'll be able to actually use this cam follow script on everything, because we're going to set it up so that you can constrain your camera in really any way you'd like. All right, let's open her up. Let's grab my cam follow script notes so I make sure I do everything correctly. There we go. Okay, so what we want to do is we're going to need a lot of variables for this. We want to bring in a lot of public variables. This is going to give the user, or you, the developer, so much control over your camera in the game. So I'm just going to start creating variables. First thing we need is a public transform, and this is the tracking target. So this is going to be the target that the camera is tracking. In our situation, it's going to be the main character. It's going to be the player. And then we want a public float X offset and a public float Y offset. This is going to allow you to move the camera over on the X and Y. So you're moving it. So here's the thing. We don't want the character to be dead center in the middle of the script or of the camera. We want to move it over a little bit, right? So this is going to allow us to do that. We want a public float. Float follow speed. Yeah, this is going to change the speed in which the camera follows your character. There's going to be a little bit of a lag, which makes it feel more natural. Public bool is X locked. We'll set this to false. This is going to allow us to lock our X movement, so the camera will not go left and right. Public bool is Y locked. Same thing for the Y. Now we're going to set this to true because we actually want the Y to be locked by default for this game. We don't want the camera to go up and down. Let's see. Then we want a public float min X pause. We want a public float. We'll actually spell it all the way out. Min X position. Then we want a min Y position. We want a public float. Actually, let's do max X position. We'll keep the X values together and then the Y values together. So min X and max X, and then we'll set min Y and max Y. Okay, so those are going to allow us to set constraints on how far the camera can go on the X in both directions or on the Y in both directions. All right, it looks like a lot of variables because there are, but actually the code itself isn't really that much. It's really just one method, just an update method. So let's do void update. Inside, we're going to set a float called X target. Ooh. We'll set it equal to tracking target dot position dot X plus the offset, the X offset. Beautiful. And we'll do the same thing on the Y. So I'm just going to go ahead and copy and paste and then change these values. So this is Y target, tracking target position dot Y, and it's going to be Y offset. Beautiful. Now we want a, let's set an X new. We'll set that to transform dot position dot X, and we'll set a Y new the same way. This is going to be how we're going to update our camera's position in the game. Now we want to check to see if, did I say is? We want to check to see if X is not locked. So not is X locked. So basically, if X isn't locked, then we're going to update the position. So we'll set X new equal to math f dot lerp. Lerp. Now lerp is basically just going to interpolate between two different points, but it's not going to do this movement automatically. It's going to interpolate between the points and then have a smooth movement from point A to point B. And so the point A is going to be transform dot position dot X. The point B is going to be X target. And the time that we want it to take to get there is time dot delta, delta time times follow speed. Now delta time is really just it's a way to kind of compute the amount of time between now and the last frame. It's a more smooth movement. It's a way to smooth out your movement a little bit more. Messed up on that. Okay, so now we have the is X locked. Let's go ahead and copy this. And we'll do the same thing for the Y. Is Y locked. Y new. Transform position dot Y. Y target. And that's the same. Okay, perfect. So now we're updating our camera based on our movement, or based on the tracking target. Okay, so last thing we need to do is we actually need to clamp our X and Y based on our minimum and maximum positions. So we're going to say X new is going to be math f dot clamp. This is going to set a range of possible values, and it will not allow the X to grow out of those values. So the clamp is going to be X new min X position and max X position. And then we will do the same for Y. Copy, paste, Y new, min Y position, min or max Y position. Perfect. Now there's one thing we have left to do, which is basically just update put all these new values in and change the transform position of our camera. So transform dot position equals new vector 3 x new y new transform dot position dot z. Okay. Now the reason why we're using a vector 3 is because cameras are always 3D objects. Even in a 2D game, the camera is a 3D object. So it needs a vector 3. So it needs an X, a Y, and a Z. Okay. Perfect. At this point, our camera follow script works. Let's go ahead and save. And go back to Unity. I can't remember if we added it to the main camera yet. So, yep, we did. So now look, all those public variables we created, they're now here for us to play with. So let's set our X offset to, let's try 2 at first and see if that works for us. Let's try follow speed of 2 as well. Our min X position. So what we want to do is let's move the camera to the minimum possible area we want it to be in the game, and about negative 2.35. So we'll say that, negative 2.35. And then let's set it to the possible maximum, the farthest we want the camera to be able to go in our game, which is right there, 98.31. Okay, so our camera will never go outside of the range of our game. And actually, I'm just going to set that to 98. Okay. All right, let's make sure our camera comes all the way back. Now, as you'll notice, watch as I move this camera on the x-axis here. Notice that all of the art assets in the game are set up perfectly within the bounds of this camera, right? That's by design. I wanted to make sure that we can lock down the Y on the camera, and it would be totally fine for this game. Okay. And we can leave min Y position and max Y position alone. Let's go ahead and play this game and see if it actually works as intended. All right, so, oh, it doesn't. You know why? Because we haven't set a tracking target. So let's grab our player and drop them in there. And now let's play the game. Okay, so you'll see that the camera follows me as I go through the game. There's a bit of so notice that there's a little bit of a lag, right? And I'm not directly in the center of the screen. That's the offset. The lag is the follow speed. And I can actually change that to make it a little bit faster. Let's try 3 and see if that feels better. That does feel a little better. I like 3 a bit more. Okay, cool, perfect. So, and I can go all the way through the level. And when I hit the end, I can't actually go any further than the end. That's exactly what I want. Okay, so our camera follow script is working perfectly. Next, we want to set up the functionality for our parallax. So let's go ahead and create a new parallax script. So a C# script, parallax. And if you forget how to spell parallax, I have parallax camera right up here, P-A-R-A-L-L-A-X. I always forget how to spell it. All right, let's open up the parallax script and let's talk about what we want to do here. It's actually pretty simple. The parallax script will just allow us to set an offset and a background speed for the 2 layers, and then will allow us to just kind of scroll those layers based on the player's position. We don't want the layers scrolling constantly. We only want them to scroll in relation to where the player is on the game on the screen. Okay, so let's set up some variables here. First, we want a public renderer We'll call this background. We want a public renderer. We'll call this foreground. These are just the two art assets that we're going to bring in that will actually be moving. We'll set a public float foreground speed, and we'll set that equal to 0.002f. We don't want this to move fast at all. We want it to be subtle. All right, and we'll do another one for our background. Oh, I actually want the background speed to be 0.02f. So we'll make our background speed 0.002f, and the foreground speed, let's make it 0.006f, because we want the foreground to move a little faster than the background. Okay, and then we want to offset. Public float offset. We'll set that equal to 0.5f. All right, then we just need an update method, void update. Inside this update method, we were going to create a new float called background offset equals offset times background speed. And let's set a foreground offset equals offset times foreground speed. Again, we're just using the offset values to create a little bit of a difference between the two. And then background.material, yep, dot main texture offset equals new vector 2 background offset 0. So what that's doing is we're accessing the main texture offset of that background material, and we're applying it. We're basically saying, hey, apply our background offset, this custom background offset that we've set up. And we're going to do the same thing here with foreground. Oh, and I'm just going to copy and paste. Now we can do as many of these as we want. We can, instead of just background and foreground, you can have 3 layers, 4 layers. It's completely up to you when it comes to parallax. I find that busy parallax systems tend to be a little bit distracting. This is going to be a very subtle parallax, but it's going to be huge in terms of how it makes the game feel. Okay, so that's all done. That's good. That's a very simple script to write. No errors, good. Now we want to drag this parallax script onto our parallax camera here. So let's do that, drag it onto parallax camera. And when I look at it, notice that I have this background and foreground that I need to supply. If we click the arrow next to parallax camera, I have a background and a foreground. So I'll just drop those in there. Background, foreground. Beautiful. Now there's one more thing we have to do. Because this parallax is going to be based off of the player's movement, we have to update something. We have to allow our player to update the parallax at all. We've got to give it some way to update the parallax. My video has been frozen this whole time. 18 minutes. Do I stop recording or do I keep going? We're really almost done. I don't know how long it went. I'm going to finish and then we'll see. All right. Okay. That's embarrassing, but whatever. So there's one more thing we have to do with parallax, which is we have to go into our player script here and we have to create a new variable. We'll make this a public variable. Public parallax ref. All right, and that is going to be we're basically going to be attaching that parallax script from that parallax camera object so that we can get access to a specific value within that parallax script. And so down here at the bottom of my update method, I'm going to type parallax ref.offset, and that's going to be set equal to the transform.position.x. What that means is we're basically changing the offset of the parallax based on the position of the character, which is what that's the whole point of a parallax. All right, let's save this and let's play. Oh, actually first I need to click on my player here. And I need to bring in that parallax reference script. So I'm going to grab the parallax camera here and drop that in. Now if I play, we should see some parallaxing in the background, and you can see the mountains are moving very subtly, but it gives this really cool illusion that those mountains are deeper in the background than we thought they were. Very subtle, very, very subtle, but it's very powerful in terms of the illusion that it puts off. I love it so much. I could do this all day, but I'm not going to. Oh, hey. Cool. Perfect. So once you're there, once you're at that point, you can go ahead and, turn in this project. In the next couple of weeks, we're going to spend some time finishing up, making sure we can collect these, make sure we can get hit by the spikes and go back to the beginning of the level. Make sure we can trigger the mains or the end scene whenever we win the game. All of that stuff, that's all coming up, and we're going to be doing that in the next couple of weeks. Until then, I'm going to go see if I can fix my camera, and I'll see you next time.